Hi everyone, welcome back. In this video I want to make an OpenCV project, and this project is already my own project which I already met with a problem in my job. So I want to show you also how I solved it, and with the help of OpenCV functions. And these OpenCV functions I'm gonna use, which we already learned in our tutorial series, and this is gonna be a helpful video for us. So we are gonna see how we are using these OpenCV functions we are learning in a real life task, in a real life project. Okay. Before starting, maybe I need to talk about the problem so you can easily understand the target. In our project, we are colorizing the images. For example, there are some old type of images which user entering, and we are colorizing them with a model. This is not related with the project we are gonna do now, but we are basically just colorizing the images with a model. But in some cases, users are entering already colorized images. For example, they are entering this kind of images. Maybe they want to check our applications, or they are wrongly doing that. But in this case, we cannot colorize this because this is already a color image. So in this case, we need to ignore these kind of color images. We only need to focus the black and white images. So the target in this video I want to talk about, the target is understanding the image is color or black and white image. Maybe you can directly tell me, okay, black and white image is already gray channel images, so it's gonna come only with one channel image, so only counting the channel numbers is gonna give you the result. But it's not like that. Since these are all JPEG kind of coming to us, they are all in 3 channel images, and in most of the cases, even old images, they are not directly one channel, and their channel values, their channel pixel values are not same for each channel. For example, red, green, blue, they are not same. The pixel values are not same for each. So basically we are gonna I'm gonna show a simple algorithm, and in the code part we are gonna understand more clearly also. Before starting, maybe I can little talk about which functions which we already learned I want to use in this video. Split function I'm gonna use. I'm gonna use absolute different function also. Also I want to use which one, mean function I want to use also. These 3 functions I want to use, and I will solve the issue with the help of these functions. Okay. Maybe we can start by reading the images. Already 10 images here, so I already named from 1 to 10, so we can easily read them with a counter, with the help of a counter. Let's define a counter and open a while loop, and this counter is gonna be plus plus, so it's gonna switch to each image in each loop, and in here smaller than 10, so this is gonna read until the 10th image, and after that we can read our image, imRead, and here we need to specify the path. Let's start with this one and paste it. Okay, so here we are making a simple trick, just this and this. Here we need to put counter, so sorry, to string it should be, and counter, so it is done. So each loop is gonna read the image accordingly, from the 1st to the 10th. Okay. After that, maybe we can create a named window, so we can easily modify the window for better visualization. And here we can name it image. Maybe the normal window is gonna be enough, window normal. Okay, and maybe before the algorithm we can see the images little, and so we can talk about the logic I wanna apply. And okay, after that, image, then wait key. Okay, let's see the images. This is the first one. Let's see it's working first of all. Okay, it's working fine. After 10 it's out of the while. Okay. For example, this is a black and white image. By the way, you can read the correspondingly the pixel values in here, red, green, and the blue. You can see that even the each channel pixel values are close to each other. They are not totally same. So if they are all same coming to us, it's easy to understand if all of them is same. So we can decide, okay, this is a gray channel, or this is a black and white image. We can name it. So we can put this to our colorization model, but so we cannot understand because the pixel values is changing. In this one also you can see, for example, this colorized, so already is changing much between the channels. This is also, but yeah, basically the each channel pixel values even close to each other, they are not same. So the logic is gonna be, we are just gonna take the absolute difference between the channels. So we are gonna also take the mean value. So if they are so small, we are gonna decide, okay, this image is already gray, this can be get into the model. But if they are far, the mean value is higher, let's say more than 20 or 10, the pixel value I'm talking about. So then we can decide, okay, this is already colorized, we need to ignore this image. Okay, let's switch to the code path again. The next step, what we need to do is that we need to split the channels, because this is already coming RGB kind of channels. It's gonna be more accurate if we consider each channel. Okay, then we need to create a vector which is gonna hold the channels, math of channels, and here we can call, let's say, channels, and we can call our split function. Sorry, image is gonna be input and channels is gonna be output. So we, with the help of this, in the output we are gonna get 3 channels in here, which is respectively blue, green, and the red one. So also we can specify our channels. Let's say red channel, sorry, is gonna be equal to, maybe it's better to start with the blue channel, because OpenCV start with the blue one also. Blue channel is equal to channels 0, start with the 0th index, and the red is gonna be the second one. In the middle is gonna be the green channel, so this is gonna be the first index, and this is gonna be the green channel. Okay, so now I already have the blue, green, and the red channels. So after that, the next steps, I need to take the difference between these channels. So since this is 3, already 6 combination, but we need to combine just blue and green, which I'm gonna get the absolute differences between the pixel values. I'm gonna take the blue, green, and red, green, and blue, red is gonna be enough. So I need just 3, and these numbers maybe after that I need that. Okay, we can start with the absolute difference. Maybe for this I can use a temporarily diff math, let's call. Okay, and absolute difference, let's start with the blue channel and green channel. Okay, and the output is gonna be the diff math. Okay, and after this, since I already calculate the differences of the pixel values between each other, after that I can get the mean value, the average value of the difference math. So if, yeah, I need the mean value of this one. How to get that? Also, maybe we can define blue, green, let's say, okay, this is enough maybe. Then we can call the mean value, mean function. The input is gonna be directly diff math here, and this is gonna be the zeroth one, which is, since this is gray channel, I mean the one channel, so I need to get the zeroth mean. Maybe this is a little complicated, but after seeing the result it's gonna be clear. Okay, and I get the mean value of the blue. Maybe at the end I can write to the console so we can understand clearly. Let's copy and do 3 times. Already blue with green, blue with red, and which combination left? Green and the red one left. Okay, so this is done. This is blue and red will be, and this is gonna be green and red channel. Okay, seems done. We already did for 3 combination, and so I get the differences between channel, then I get the mean value of that difference math. Okay, so I can also write to the console to see the results. The first one is gonna be blue green, the second one is gonna be blue red, and the third one is gonna be red green. Okay, and now we can run the code and we can see the results. Okay, now it's telling me the difference. For example, blue and green channel is really the average between the pixels between the channels. The pixel value differences average is so small, which is 1.9, 2.9, 0.9. So the channel pixel values are so close to each other. Let's switch to the other one. Similarly, this is also small. You can see here this is really higher because this is a colorized image. So difference, the average of the difference math is higher for between each 2 channel. Yeah, and this also you see is higher, really higher comparing to the gray ones you see here. And let's see, this is also maybe we can specify the threshold accordingly, because you see here this is even the black and white image, it can come some numbers 19 and 10, not like a small like the first 2 images. And this is also similarly, there is a 13, but this is clear because there is a 58, 34, 23 and 93. This is also color because similar higher numbers, but you see here this is also lower numbers. So at the end the decision part in here can be let's say get the average first of all, double total average, and here I'm just gonna plus blue red and red green, then just divided by 3 so I can get the average value. Okay, then according to this average value I'm gonna decide my image is color image or black and white image. Let's say if total average, if this is bigger than, let's say 10, then my image is color image, and if it is opposite one, which is else, then this is black and white image. So we can simply use the put text function, so I can show with the image also the result. The image is gonna be, I'm gonna put the text, this is gonna be color image, and after that the point, let's don't risk it, so let's put just 20/20 or 30/30, maybe 50/50. I'm sure that they are more, their resolution bigger than this one. The font face, okay, this is, let's use the standard one, which is simplex. And font scale, start with 1. Color, let's use the favorite color, which is yellow for me. And after that, thickness, let's say 1. I think done. Similarly for the else, this is black white image. Okay, seems done. Let's see the result. It's so small for this. Maybe thickness should be increased. Sorry, I'm gonna increase the thickness. Let's see. And maybe increasing this also. Let's see how it looks like. Better. It's saying this is black and white image, black and white image, color image, color image, color image. So the threshold we need to increase more. Let's make 15. Black and white image, black and white image, color image, color image, black and white image. Now it's changed. Black white image, color image, color image, color image. This is also black and white image. This is the resolution is little lower, and it's done. So I hope you already understood the logic, because if an image is already black and white image, it means the channels pixel values should close to each other. So if since it's like that, we just applied, we get the differences, we get the average values. Maybe getting average values is not accurate. If you want to advance this project more better, maybe you can apply this average in the region based, or maybe not all the difference made, maybe region by region you can divide the image to the kernels, so you can apply this mean for each kernel. So maybe this is gonna give you more accurate results, because maybe some part of the, maybe a dark image, and some part of the image is really color image. So by dividing the image to the kernels is gonna give you better results, I can say. Okay, in this video I already met with the problem in my project, so I just wanted to share this with you, and also I'm gonna put this to my GitHub page. And also it's good because you see, right, the functions we learned, we are using this in real life. So this is a good experience, I believe. So I wanted to share with you, and see you in the next videos.